Hi guys, so based off what we know about systems of equations, systems of linear inequalities is about the same thing, other than we are talking about inequalities now and no longer equations. We know the main difference between an inequality and an equation is that the equations have equal signs and inequalities have symbols like these. Okay, so it is a set of two or more linear inequalities in the same variables, and here's an example of that. Okay, so we have the first inequality and the second inequality. A solution of a system of linear inequalities is when you have two variables that is put as an ordered pair, and it is an inequality of a solution of the inequality based off if we were to put those two variables back into the inequality, it would hold true. Okay, so we're going to look at this guided example together. Okay, so when you're graphing a system of inequalities, linear inequalities, you usually do the same steps you would as if it was a equation, right? You would solve the y-intercept first, plot that y-intercept, and then look at the slope and create your second and third and fourth points so you can create those lines. What is different is you look at the symbol. If the symbol is less than or equal to or greater than or equal to, we know that those are going to be solid lines as shown in the blue right here. So this blue line is solid because this is the symbol we're looking at. Whereas in the second inequality, there is no equal to symbol under this sign. So what we do is we draw a dotted line. That's our red dotted line on our graph. Okay, so step one was to graph each inequality. And then we know that we have to shade according to the symbol. Okay, so for our blue line, we know that we're going to shade below because our sign is less than, and less than tells us we shade below. So that's all this blue area here shaded. And then we know our second inequality is greater than, which means we're going to shade everywhere above that red dotted line, which is to the left of the line. So if I draw this here, we draw up to the left of the line, that's where we will draw our, or shade in our graph. And the blue would be everything below that line. And as you can see, there is an overlapping shading, which is going to be this area right here. Okay, so this whole area is called the solution, and we can pick any point here. Specifically, they picked point -3, 1, which is right here. That would be considered a solution. Again, if I took the x and the y and threw it into the equations or inequalities above, it would hold true. Okay, so I'm gonna do this practice problem from scratch with you guys, and then you're gonna have some time to work on your own problems below. Okay, so the first thing you want to do here is you want to look at these both and make sure that they're in slope-intercept form, which they are. Okay, the second thing we want to do is plot the y-intercept as my first point. I'm going to start with my first inequality, which is this one right here. I'm going to do everything in red to differentiate between the two, starting with my y-intercept, and we know that's always the last number in our equation or inequality, which is the -1. Our slope tells us that we go up 2 over 1. If we look here, what number is attached to the x? It's 2. 2 is our slope. Written as a fraction is 2 over 1, which is our rise over run. So up 2 over 1, and you can repeat. And then we look at the sign to make sure what kind of a line we're going to draw. And since we are less than or equal to, that means we draw a solid line. Since it has the equal to symbol under it, we draw a solid line. Okay, and the last thing is the shading. Where are we going to shade? We're going to shade below, right? Because the sign is less than, and less than says that we shade everywhere below that line, which is all of this stuff here. Okay, for my second inequality, I'm going to draw it in blue. Once again, starting with my y-intercept, and that's the last number. That's 3. My slope is a -x, which means there's an invisible 1 in front of there. And that means that my slope is -1 over 1. So that means I go down 1 over 1. Repeat the pattern, down 1 over 1. Again, down 1 over 1. And we know, again, this is going to be a solid line since it includes the equal symbol here, so greater than or equal to. And where do we shade? We're going to shade y is greater than symbol, so greater than tells us we shade above. And where do you notice that the two arrows, the red and the blue arrows, cross? Which shaded region is that? That is this shaded region right here. Okay, we are still above that blue line, and we are still below the red line, where the two shaded regions overlap. Okay, you can also look at it this way, maybe show another option. So we know that the red is everywhere below, shaded below, and then the blue is everywhere shaded above. And you'll notice that this little area right here is where you double shade or you have overlapping shading. Okay, so anywhere you pick a point on our light blue highlighted region or shaded region here would be considered solutions. So I can pick a point here, which is 5, 3. I can pick a point here, which is 4, 1. And you're going to want to write them down below. So 5, 1 is one of my points. Another point could be 4, 1. And then we can also find another point in our shaded region. Again, it doesn't matter, 6, 6 here at the top. And that's how you would solve or find the solutions after graphing. Okay, so you want to use this stuff here on the left-hand side to tell you what kind of lines you're going to be drawing and also where you're going to shade as well. Alright, so now you're going to try the independent classwork. There's 4 problems here. Don't forget to list 3 points that would be considered solutions based off your graphed inequalities.